Section 4.1 Part 2 deals with first-order differential equations. For our first example, we want to find the general solution to the differential equation dy dx equals 3x minus 5. Remember that dy dx is just another way of saying y prime, right? It's just in what we call differential form. So basically we know we've been given a derivative with respect to x and that that derivative equals 3x minus 5. And we're trying to find the original equation for whom that would be the derivative. So the way some of this is just understanding the notation. When it's written like this in differential form, you need to cross multiply by the dx so that you can get all the y's on one side and all the x's on the other, including the differential. So if we cross multiply and we'll split the differential, and we will have dy is equal to 3x minus 5 all multiplied by dx. That is called splitting the differential. Then we integrate both sides. And that will bring us from the derivative back up to the original. What is the integral of just one dy?
Y.
Y plus
C.
a constant, right? So y plus a constant. Now on the other side, if we integrate 3x minus 5, the first term becomes 3x squared divided by
2.
So we have 3 halves x squared. And the negative 5 integrates up to just minus 5x plus
C.
a constant. Since we have two different constants here, we can't guarantee that they're the same constant. We'll let this one be constant 1 and this one be constant 2. So far so good? So basically, you just get all your x's on one side, all your y's on one side, integrate both sides with respect to the appropriate variable. Then, when you look at the end and you have your constants, I want us to go ahead and get y by itself so that we have y equals 3 halves x squared minus 5x plus constant 2. And technically that would be minus a constant 1, right? But if I have two constants added or subtracted, you just have a single constant. Do you agree with that? If that were 5 minus 7, it would be negative 2. If that were 3 minus negative 7, that would be a positive 10. So what we're going to do is just combine these two constants and let them stay one general constant. So what a lot of people do when they solve differential equations like this for the general solution, they simply just don't ever put a constant over here, and they just understand that we're going to put all of our constants on one side. So it'll just save you a couple of steps there. So for our final answer, we have y equals 3 halves x squared minus 5x plus c. For our second equation, we're going to look at dr d theta equals pi. So basically, some equation with respect to theta has a derivative of pi. In order for us to figure out what that equation is, we're going to cross multiply so that we will have dr equals pi times d theta. Now we want to undo the derivative and bring it back to the original, so we're going to integrate both sides. And the integral of dr would just be r plus c, right you guys? Well, we've learned that we're just going to save all of our constants for that final step over there on the right. Just go ahead and combine them into one. Now pi is just a constant. So really, this is the same thing as integrating like a 3. So this would, if this were a 3 dx, then it would be 3x plus c, right?
Yeah.
But this is a pi d theta. So we have no thetas right now, but when we integrate, one's going to pop up, just like an r popped up here. So the integral of d theta is just theta. So this side will just be the constant pi times theta plus c. And if you imagine taking the derivative of that, the derivative of r would be r prime equals pi plus 0.
You don't add an x because we're using theta.
Right, yeah, you really just add in the variable that's there. So x's are easier for us to visualize, but you just treat it the same as if it's an x, but with whatever variable your differential is with respect
Because
to.
at first I put I x theta, and now back I really want.
Right, you wanted to put an x as well as a theta? Yeah, just takes like some kind of training to get used to. I have to like really stop and think about them if they're not x's or y's. Y's are pretty easy, but the r's and the s's and the thetas throw us off a little bit. Is this okay? Let's try another. This says that dy dx equals 2x to the negative 3, and we are just trying to find the general solution. So we'll pause and let everybody have a chance to do that. So you guys said that you got the answer y equals negative 1 over x squared plus c. So let's work through that. First, we cross multiplied. We had that dy was equal to 2x to the negative 3 dx. Then we integrated both sides with respect to the appropriate variable. So this one technically would be y plus a constant, but we're going to save our constant for the right side. So we'll just say that this one is y equals, applying the power rule gives us 2x to the negative 2, divided by 2, which would be 1x to the negative 2, divided by negative 2, right?
Yeah.
So it would be negative x to the negative 2. Plus, we'll put all of our possible constants over there. So this gives us y equals negative 1 over x squared plus c. And so we had the question, does it matter, that it says general solution? And in the next slide, we're going to see the difference between a general solution and a particular solution. But a general solution just means that you're going to have that general constant on the end when you're finished. A particular solution is going to be where you're given enough information to solve for that constant. So rather than a plus c here, maybe we would have like a plus 5 or a minus 4. But for now, we'll just leave it alone as the general solution.